Okay, so we're looking at transformations of higher order polynomial functions. So you do a lot of quadratics in grade 10, and then you add a bunch of different kinds of functions in grade 11, and you talk about the transformations of all those functions. And we've been looking a little bit at like cubic and quartic and quintic, so degree 3, degree 4, degree 5, and then hopefully you've got a sense of the pattern as you go up to degree 6, degree 7, degree 8, degree 9. We don't look at a lot of those, but you could consider some of the pictures that we had were like degree 8 and degree 9 functions, right? So we know how the pattern goes as we go to even and odd. So that's what we've started to look at so far in grade 12. We're going to step it back a little bit and look again at some transformations, but let me show you something. So there is a very typical looking, the green function there, that's a cubic function, okay? So degree 3. It's got a positive leading coefficient, so it comes up from quadrant 3. It does that cubic twist and then goes up eventually into going into quadrant 1. Very different from a cubic that looks like that. Okay, so I'll zoom in a little bit, but look at what happens in this one. It doesn't have a cubic twist. It has 2 turning points. Okay, so that's, and we've looked at these kinds, but that's a different one. Okay, and then same thing, here's a very typical quartic. Looks kind of like quadratic, kind of like a parabola, but its turning point is flatter. It looks a little bit different. If you think about the math there, then that would make sense. Why? And then again, here is a very different looking, but still quartic degree 4 polynomial. So this kind of polynomial function and that kind are not what we're talking about today in the lesson. Okay? What we're talking about today is these basic kinds. When we talk about that just has the twist in it, or kind of just looks like a flat parabola. When you transform the function this way, as we have seen with all the other functions that you look at in grade 10 and grade 11, with the a value, the k value, the d value, the c value, is very familiar, right? And trig functions as well, we do the same kinds of transformations, although they look a little different. When you transform a cubic or quartic this way, you don't get the ones that go up and down and up and down. Okay? You can't express those this way. So we express those in factored form, and then we only look at this for one day in basically this whole entire course, that, hey, there is this basic form of higher order, and notice if it's a 3, obviously it's degree 3. If it's a 4, it's in degree 4, and then you could increase that to obviously 5 and 6 and keep going. And it's in this like transformation type form, almost like quadratic's vertex form or whatever you want to call it. That makes sense? So that's what we're looking at today, but it's very basic, very straightforward. Basically, that's the lesson. I'm going to show you one other thing, but basically that's the lesson. And so A is your vertical stretch, compression, and possibly reflection in the x-axis, and then all the bits that we know. If the magnitude of A or the absolute value of A is greater than 0, it's a stretch. If it's that should say greater than 1, less than 1, that should say less than, then it's a compression. And if it's less than 0, it's negative, it's a reflection, and so on. And K has the same idea. And then D is the horizontal shift, and C is the vertical shift. Everything's the same. Same exact way that we have talked about it. Does that make sense? Okay, so there's an activity, it's posted to the classroom, and it sort of walks you through the different ones, but again, it'll be very, very easy, very straightforward for you at this point, but it's worthwhile doing. Okay, there's a couple of little things in it that are good sort of thinking steps, so give that a try after the quiz. We're going to do the quiz next, but give that a try after the quiz. And it just lets you think about the transformations, what a shift does, and how the different stretches and compressions, how it impacts the graph. So the last thing that I want to do is I'm just going to show you some sort of, we're going to randomize this and take a look at what different graphs could look like. So where's random view, recompute all views. So again, this is just randomizing the values of A, K, C, and D, right? So that's all that's happening here. So this one looks like it's very much stretched. It's shifted to the left a bit and down a bit. And whether that is a vertical stretch or a horizontal compression is hard to tell. We've talked about that a little bit, but that's what's happening there. Okay, and recompute again. So then this one's shifted in a different way. But again, look at, no matter what I do, changing those 4 values, A, K, D, and C, it always has the same sort of basic look, like a, right? With that cubic twist in it. Whoa, so I'm gonna have to scroll out to see this one, but if I scroll way out again, it looks very similar. So do you see what I'm saying? How this is a very different graph from, again, one that looks, whoops, I'm gonna scroll in to see this one. One that looks like that goes up, turns, comes back down, goes back up. Okay, and then what about Quartic? So no matter what I do, it's always got the same kind of flattened parabola look. Different from this one that still has the same end behavior. That part we can do with leading coefficient no matter what. But it's what happens between the ends that can be different depending on the shape that it's in. Any questions about that? Pretty straightforward. Okay, so you do a little bit of graphing in this. I want to show you something because this is my trick for graphing. Talked about it a little bit, but and again, I don't think you need to write this down. Just watch. If you were going to graph these, the trick that I would do is and this will work for any kind of function. Okay, when you're doing transformations of a function, which again, when we were doing factored form, the last couple of days we did some sketching of these guys written in factored form. That's not transformations. That's not a shift this way, a shift that way in a compression. Like, you don't talk about it that way, right? We look for the x-intercepts, the y-intercept to get a sense of what the graph looks like and the end behavior. So that's different. But if you're talking transformations, then this is the little trick that I use. I think about what the actual function is. So in this case, the function, like that's right there, defines the function. It's a degree 3 function. It's a cubic function, okay? And it's in this transformation form. So every parent function that you talk about is a little bit different. You got to kind of figure out where the starting point is. But then from there, you can do your shifts. So for example, with quadratics, the vertex is impacted by the shifts. And then from the vertex, what I would do for a quadratic, okay, so we're going back into quadratic mode here, is I talk about the overs and the ups. So and this is thinking about the type of function and the growth of the function. So if I go over 1, squared is up 1. If I go over 2, I square it to figure out how much I go up, because the input is what I choose, and the output depends on the function. In this case, if it's quadratic, the output I square it is 4, input 3, output 9. And then what you can do, this is for the base form, right? And then what you do is, if it's a horizontal compression, you're dividing the overs. If it's a horizontal stretch, you're multiplying the overs. If it's a vertical stretch or compression, that's not going to change the overs, but it changes the ups. So from your vertex or whatever it is, you can change those things. So then if you think about a cubic, even if you've never really seen one before, we've seen them a little bit, but even if you've never really done this before, well, I'm going to go over 1, 2, 3. What are my ups going to be? 1, 8, 27. And I can continue that pattern, right? And what if I go over -1, -2, -3? -1 cubed is -1. -2 cubed is -8. -3 cubed is -27. So you're actually going down in that case. And that's why it has this look where it doesn't turn and go back up. Does that make sense? So think about that a little bit while you're graphing these. I think that makes sense. And then I can do the same for a quartic. Over 1 would be up 1. Over 2, 2 to the 4th is 16. Over 3, up 81. So that's going to be hard to fit on the graph, but you get the idea of how that one grows very quickly. Does that make sense? Any questions? Okay, that's it.